The generator, you can see, is going back together. It's coming around pretty good. I'm getting ready to assemble the electrical part of it, the generating part of it, but I want to explain how the generating part actually works. And so I've got a coil of wire around a broken tap. This was my iron core, and keep an eye on, this is what you're going to keep an eye on right here. And in my hand I have a magnet. Okay, and what you do, I'm going to pass this back and forth in front of this. If you watch that, you'll see that I'm making electricity. You stop, as long as I'm moving it, it's making electricity. Okay, and that's a magnet passing across the front of a coil with an iron bar behind it. That's how we're making electricity and how a generator is going to make electricity. So we're going to go over here, and I'm going to show you. Let's start over here first. We have a coil here with an iron core, and then we also have a set of coils over here with an iron core all the way around it. You can see these iron cores in here too, and the wire passes in between them. So we don't have a magnet. This is not a magnet. Let me get my little piece of metal here. You can see this is not a magnet. Nothing on here is a magnet. Nothing on here is a magnet. That's that tap. So there's no magnet. So then we have to make a magnet, and we're going to make a magnet right here. We're going to turn this set of coils and this whole thing here into an electromagnet using these brushes, and those brushes are going to ride on here, and we're going to put power into here, which is just the opposite. I'm going to make a magnetic field with electricity, and that's what's going to happen. We're going to put power into here. This thing's going to have a charge into it, and it's going to be rotating because it's tied to the crankshaft of the engine. Inside of this, which is that magnetic field, is going to be doing exactly what I was doing when I was running this back and forth like this. It's going to do the same thing. This is going to go around passing these coils, going positive, negative, making power. And that's how that works. We're actually going to put power into this to make an electromagnet, and it's going to pass by this for all these windings, and that's going to generate the power that we need. So how do we get enough voltage? Because we're talking, this is rated at 7,000 watts. So watts is voltage times amperage. It gives you watts. Well, we have to do it in cycles. So this is a cycle. This is one rotation of that armature right there. So this goes up and then down. It goes into positive, then it goes towards the negative, and back into right here, going to positive. This is one cycle. And in the U.S., our electricity is set at 60 cycles. So that's what we're going to be doing. We got to get 60 cycles to generate the power. There's enough windings in there to kick up the voltage that we're going to need in the amperage. So we can, amperage is the draw, the movement of electricity. The voltage is the potential. And we're going to make the potential, whatever we're going to have, the piece of equipment we hook onto it, like an electric heater, it's going to have the amperage. It's going to draw the amperage. It's going to go up. There's 7,000 watts of power generated. That's as simple as it is. So if we have a break in any of these wires, it's going to interrupt that magnetic field, and it's going to stop generating. That's the simplified version of what's going to happen here. And that's where I wanted to start, because I'm going to reassemble this now. And before I did that, I'm going to have to clean these up. These brushes are carbon. You see that? This is a brush holder, and these brushes are spring loaded to push against this armature. And these are right here. It rides on that, and it's stationary. The shaft is rotating, but these are dirty. You can see that they're dirty, and they're going to need to be cleaned up. And that's what I'll do before I reassemble this. I'll clean all this up and reassemble it, and then we'll be ready to finish up this project. Ended up on the last video, the short video I had. I was talking about an electromagnet, and I wanted to show you how you can make a 12-volt battery will make a magnet. I'm putting them around here right now, and we've made a magnet. So by passing wire or electricity around this coiled wire, around a metal rod, and I'm putting 12 volts through it, and I'm making a magnet. See that? And if I leave it there long enough, this tap will become magnetized. You can actually magnetize a screwdriver the same way. It's a magnet now.
And that's just hooked on.
I'm passing 12 volts DC through the wire. This is making like a resistor, and it's making a magnetic field around that. It's actually embedded into this. This is probably still magnetized. Yeah, a little bit. Not as strong as it was when I was putting power, but it's still magnetized. Right. That's what's going on in the generator. So let's go look at the generator. You can see the generator's really getting close to being completed. We'll walk around that in a second, but I want to show you, this is what I was talking about. The brushes is going to have DC voltage. It's going to generate a power. It's going to go through a rectifier. The rectifier is going to turn AC voltage into DC voltage, and this DC voltage is going to sit on that area where I showed you earlier that I had to clean up. It's going to sit in there against that, put DC voltage on that shiny copper pieces, and energizes that armature. And that's going to rotate, and that's going to make the power, and that's going to come back through this and go up into all this. These outlets and circuit breakers. And if you look inside here, you can see there's a lot of wiring. And one of the things that in electrical is the smartest thing they can do is put numbers on things. These numbers correspond to these numbers. See that? Mm-hmm. Same thing as what's down here. 22, here's a 22. 0 is a ground. 13 is up here somewhere. 13, 22, 22. 13's back there. 13 goes back into this little thing in the back here. And I'm not even sure what that is. That must be a thermal switch or something. Oh, it's for DC. This is the DC outlet. So 13 turns into 15 after it passes through that. There's a 12 volt DC outlet on the front, and that was missing. The wires that were hanging out of the front of this at the very beginning, that was a 12 volt DC, that direct current outlet on the front of this. So you can see I'm really close to finishing up this. All I got to do is hook up the wire here. But let's walk around this thing and see what all I've got done. I don't have the tank bolted down yet because I'm still finishing up stuff. But I've cleaned up all of this. And all this is back where it was. If you remember right, the carburetor was hanging off or gone. This was hanging off of it. These switches were disconnected. None of this was here.
This was just rusty.
That was really rusty, and this is the repair I did. I did it on the back side. You can see it right here. Yep. And I'll talk about when we go to do the
this was just all peeling paint.
Peeling paint off everywhere.
So nice.
It's looking a lot better. Carburetor's on it. Uh-huh. Let's go around the other side.
Did you new tires?
New tires and wheels because those are shot. Uh-huh. I haven't hooked I do have in the bottom of the tank. You can see I've put the fitting in there, right here. Mm-hmm. The hose will hook onto that. I'm not gonna hook this up right now because I'm gonna test run it with my other tank. Okay. That'll be hooked up. The battery was mounted up underneath here. Let me get that real quick. This here, it bolts up underneath there and holds a battery, and then these leads come up here and hook onto the battery. But that's so hard to get out of there. Another generator I have in there has a bracket mounted down here and it holds the battery, and it's actually better. And I may make a bracket to put it down here and not go back up here. This is a bad idea because you have to pull the tank to get to the bolts to unloosen it.
Oh, okay.
and I don't like it.
I see.
But everything is coming back together. I want to go over when I get all the wiring done and we're ready to run it. I'll go over the materials that I used
Okay.
because, and I'll explain why I did it.
Okay.
But it's looking a lot better.
Mhm.
It's very close to running. I
Mhm.
cleaned everything up inside here, all the stuff that I was worried about, and I've got this all cleaned up. Everything here. I'm checking all the connections, and then I'll put the cover back
And you've
on.
got that faceplate all painted.
I got the
ready.
plate painted, and we're going to put some labeling back on it.
Okay.
But it's looking good. Oh, one other thing.
Mhm.
All right, so the gas cap. I did find a gas cap. It's not for this brand, but I found one that went on. The gas gauge one, I've got two of them now that have the plastic piece broke off. If that's gone, then water can get into the tank. And you got to have this vent here. So I looked for a gas cap. I said, well, it's better to have a gas cap without the gauge, one that will keep the water out of the tank. And that's what I got here.
Okay.
So I may go back to the gauge later, but I keep the water out of the tank.
All right. Is that it?
That's it for now.
All right. Thank you.